Here's our directions for checkpoint 3. Make sure you read this summary box at first so you know exactly what you'll be turning in when you're done and you don't submit it with something missing. There are some questions in the explanation of evidence box, a data table, and a few more questions in interpreting the data we get. As always, if there is background information, please read it. It'll help you with some of your questions and understand what you're about to do. So there are two parts to this checkpoint, and both will be done by clicking on this simulation link. These directions will kind of tell you what to press, but I'll just show you in the video as well. If we click here, it takes us to our simulation page. We're going to click on the second tab that says motion. I'll double click and I'm in. In the checkpoint, it says to check all of these values in this yellow box at the top right. So I made sure I did that. And when I go back, it says I'm going to use the arrows at the bottom to slowly increase the amount of force applied until the box starts moving. Slowly is the key here. I'm going to look at these questions now so I know what I'm looking for. And one of them is going to be how much force does it take to start moving the box? Okay. Why do I need to apply a force to get it to move? How much force do I need to make it stop? Which of Newton's laws is this? And remember, if you're confused, these laws up here and a definition to help you with this law are up here as well. So really, the two things I'm looking for is how much force does it take to start moving this, and then how would I stop it? So let's go back to our simulation. To apply force, right now it says 0 force, and you can see the box is not moving. I just click on this. It's not moving. I click again, not moving, click again, not moving. Well, it's kind of moving, so if you think that's moving enough, it does have speed, you could record that value for your answer here. Why do you need a force? That's a question you'll answer from background information. How much force do you need to apply to make it stop? To do that, you'll have to click on these buttons. The buttons that'll turn this person around, make him push backwards. I'm not going to do it for you, but you're going to do it slowly like we just did, one click at a time until this stops or even moves a little the opposite direction. And that's how you'll answer question 3. And then you're going to tell me, is that Newton's first law or his second law that we're talking about? Once you're done with that, you're going to click on, well, you're already there, so if this is the same sitting, you can just stay where you're at and click on all the same boxes. But we're going to fill out this data table. We're going to click, figure out how much force it takes to get these different objects moving at a speed of 5 meters per second. All right, how do we do that? Let's start over. Click all my boxes that are in that yellow box in the top right. Then I'm going to do the first object, which is a box. I'm going to click just like I did before, except now I'm not going to stop until this value for speed says 5.0. So give it a second. It's slow. Nope, not going, not going. I keep clicking fairly slowly. It's going to increase a little, but it's nowhere near 5. And eventually, I'm going to get to where it says it's going 5. Once I get it at 5 meters per second, the mass, how do I know what the mass is? It tells me right here. It's 50 kilograms. So that's what I would put for my mass. And then the force that I needed would be whatever value it was down here when this said it was going 5 meters per second. So again, I would click, click, click till that said 5. I'm going to skip way past 5. What's going on? Oh, I forgot to hit play. So this is way too big of an answer. You can see it's jumping up to like 100. But if it were my answer, I would put 254 here for the 50 kilogram box there. Then I'm going to reset. Click my values. In my second data point, it says box with a girl on it. So I drag the girl, click her up there, and then I do the same thing. Slowly click until this value says 5. Notice my mass now, I have to add 50 plus 40. That would go here, whatever 50 plus 40 is. And the value that goes here is whatever number appears here when I click real slowly, and this reaches 5. I'll keep doing that over, swapping out the girl for a man, and then the man for a garbage can, and then getting rid of the box altogether and doing a fridge. And notice there's a blank down here. That's for you. You can pick anything you want. or any combination of things, just make sure you record what thing or things you were doing down here, what's their mass, and how much force it took to get them moving at 5 meters per second. After that, you have 2 questions you must do. What is the pattern you see behind the mass and force you need to get to 5 meters per second? In other words, as the mass goes up, do you need more force as these go up, less force, or does the force stay the same? And then which of Newton's laws is that referring to? If you want, optional for B, explain how that law is shown by your data. And then for an A, which I should put here, and I will, actually I'll do it now while you're here. You're going to graph your data. And if you do that, you're putting the mass on the x-axis, the force taken to get 5 meters per second on the y-axis at Desmos. If you don't remember how, go back to the earlier checkpoints. I show you exactly how to make the graphs, but since it's for A only, I'm not going to put that information here. Once you're done with all that, you can turn in your checkpoint.